Hello everybody. Hopefully your family and you are doing well and healthy. This is Unit 7, Lesson 3, the learning target. I can write and create exponential decay functions by working with real world word problems. And there's a do now right here. It says consider the following scenarios. So there's scenario A. You earn $100 each day and every day. And scenario B, you earn 1 cent on the first day. Then following that, you earn twice what you earned the previous day. Which scenario is better and why? So we want you to do here, before I tell you to press pause, is identify each one of the scenarios as either linear or exponential, and then figure out which scenario is better. Okay, press pause now. So if you said linear for the first scenario, you are correct. And if you said exponential for the second scenario, that is correct. The key word in the second scenario is that word that says twice. It's like doubling, right? So it's doubling what you've earned the previous day. The scenario that's better is obviously B, because it is increasing at a faster rate, obviously. So you don't want to just earn $100 each day. You want to have 1 cent on the first day, and then it doubles the second. Then whatever you make on the second, it doubles and it doubles and it doubles. You earn twice what you've earned on the previous day, and then that would be faster because that would increase at a faster rate. So now, just going a little bit into this, can anybody tell me what that equation would be for scenario A if it started at 0, as far your initial value is 0, and you earned 100 each day? All right, would be y equals, remember it always has to be y equals mx plus b. So in that, what would it have to be? So you know that that b is the 0, that's the initial rate, and it would be y equals 100x. Hopefully you understand what that is. And remember, 100 is the rate that you're earning in each day. But scenario B, remember, that is an exponential rate. So we're talking about an exponential formula. So remember, y equals, remember what that formula is. Y equals A times B to the x. So press pause and try to figure out what type of equation you would put together. I'm going to press pause now. Okay, remember, always have your key set up. Yikes. We have A equals, and what is your A equal? I always think of the A when I get the first letter in the alphabet. It's the first number, that it's the initial kind of like value of what is going on here. The initial value is 1 cent. So if I'm going to put 1 cent down, I'm going to put 0.01 for 1 cent. And then I'm going to put B, and my B is that next number, that multiplier, right? How much is it? How much am I going to earn? So it's twice the amount, and it's going to be 2. So when I go ahead and substitute into this formula, I'm going to have y equals .01 times 2 to the x. The x would be like the time, but we don't have that. This is just a formula that we're going to use. That's it. So the next page is an explore. It says in the last lesson we learned about exponential growth. It's an increase. Anytime that we have exponential growth, we're talking about interest. As far as earning money in the bank, exponential growth is just what it says. It's a growth. In this one, we're going to talk about exponential decay. And remember, exponential growth, the formula it was y equals a times 1 plus r to the t. And that was growth. Decay will be the same formula, but instead of 1 plus r, it's going to be 1 minus r to the t. All right, so a is still the initial amount. The r is the rate of decay in decimal form. You're going to subtract it at this time. T is still the time. And 1 minus r is the decay factor instead of the growth rate. All right, for exponential growth, the value inside the parentheses is greater than 1 because r is going to be added to 1. In this case, exponential decay, the value inside the parentheses is going to be less than 1 because we're not going to have, like, say if we start out with $100 and we have a percentage being taken off of that 100, so it might be worth $80. It's kind of like when you buy a car, when you buy a computer, there's always like a rate of decay in decimal form. So like we lose the original value from the original value of what it is. And basically, we're going to see those types of questions coming up. All right, so here we go with exponential decay, and we're taking a look at y equals a times b to the x. It's always that formula. So instead of the, remember when I told you instead of that 1 plus, it is 1 minus. And you notice that in the parentheses, it's 0.5 now. It's not a number that is greater than 1. It's a number that is less than 1. All right, b is going to be for decay. B is going to be in between 0 and 1. And the graph, and you could always tell an exponential decay graph, is that it's going down instead of up. Exponential decay goes down. So this question right here, just asking, is this an exponential growth question or decay question? Let me just move this down here. 5 years ago, flat screen TV's cost on average was $2,500. There has been a 5% decrease per year since then. What would the average cost be today? So obviously, what would this be? Would this be a growth or decay? If you said decay, you're correct. What is that key word that you're keying on here? The key word is decrease. All right, so there's a decrease, a decrease, and that is your keyword that says basically you have to subtract. All right, you have to use the 1 minus r, not 1 plus r. So pause the video and see if you can figure this out. Use the formula. I have the steps on the side, and see if you could use your calculator to figure out the final answer. Press pause now. So if you're up to this, hopefully you did, and make a key. Hopefully you have your A as 2,500. You have your R as 0.05 because it is a 5% decrease. So you have to change that 5% into decimals, 0.05. And then the last thing that I did not put in there is the T. And so right now, I have to put my T. So what's my time? If you said 5 years, then that's correct. All right, so basically when I go ahead and put this together, I have y equals 2,500 and then I just put the whole thing into the calculator, but you have 1 minus 0.05 and then to the 5th power. So if you have your calculator out, hopefully you do, and you have your equation all set up like that, you have 1 minus 0.05 to the 5th power. And you press enter, and you get that. And that is what the 5% decrease, the TV started at 2,500, 5% decrease per year. All right, so then you would 1,934.45. And that would be your final answer. Okay, for the next page, just go ahead and see if you could handle this one. It says, which formula do I use? And you see how there's on the left, I just want you to get used to looking at both formulas and seeing the difference between the two, where the growth is 1 plus the rate and the decay is 1 minus. It's not really that difficult of something to, kind of remember. It's the same formula. The X is the T, is the time, and that's basically it. So when you read a question, it either says decrease or increase. It says doubled, tripled, or decreased, by half. So if it says decreased, use decay. If it says increased, doubled, tripled, use growth formula. Okay. See if you could do this and figure out the answer. Use your calculator. Press pause now. So hopefully you have your key down, which is on the left, the A, which is your initial amount, 16.5 gallons, and the rate is 4.1% a year. It's a decrease, but either way, you have to change that percent to a decimal, which is 0.041. The time, it says model this with an exponential equation and find the estimated number of gallons in a year in 2020. So it starts in 1990. So you take 2020 minus 1990, and it's 30 years. So that's your T, 30 years. So it's y equals 16.5 times 1 minus 0.041 to the 30th power. Hopefully you did this part already. you grab your calculator, clear that out, and you have 16.5 times 1 minus 0.041 to the 30th power. And you can press enter. All right, so it says find the estimated number of gallons. All right, so if it says find the estimated number of gallons, I'm going to put y equals 4.699 gallons. On the estimated number of gallons, that would be 5. And whenever you're putting, and it's per year, just so you know, I don't know how to do it on the actual computer, but it's like a squiggly equal sign, kind of like that, where it's y, it means approximately 5 gallons per year. That's if you put that. All right, just wanted to kind of put that down there for you, and that's your answer. This is something that's very important to understand, because they could really ask you all types of questions based on growth and decay, and they would ask you what's the percent, and you would have to know what the percent is based on what they give you. So this growth or decay question mark, percent of growth or decay in a given problem must be converted to a decimal first and added to 1 and subtracted from 1. An example is 6.1% growth is a base of 1.061, which you add 1 plus 0.061. And with what question they can ask you here, I just wanted to make sure you understood. They could ask you, they could give you this number. And they could ask you, this is an exponential growth. Obviously, you would have to know that because the number is greater than 1. And they would ask you, all right, what's the percentage of growth based on that number? I did a bad job of circling it, but and then you would have to say, all right, it would have to be 1 plus, and then what is 0.061 as a percent, and you would have to convert it back into a percent, and then you would have to say, oh, all right, it's a 6.1% growth. So like if I gave you a 1.055, is that number represent, this is B, that's your B, does that number represent a growth, or does it not represent a decay? And if you said growth, then you're correct, because that number is greater than 1. All right, so now since you know it's growth, it would be 1 plus, and then you would have to give me the percentage of what that growth was. Right? So does anybody know what that percentage would be? 5.5%. And that's what the growth would be. And the same thing as far as the decay goes. And this is decay, it's a base of, the B is 0.975. Because you're always subtracting 1 minus, you have to figure it out. 1 minus the 0.025, and that'll give you 0.975. So the decay would be, in this case, 2.5%. those are the types of questions that definitely on the Regents that you can expect. All right, that's reading into the problem. Those are multiple choice questions that you can definitely have. All right, we'll get into it a little bit more. All right, next problem. Plumber charges $22 per hour. The hourly rate increases by 3% per year each year. Write a function that represents the plumber's hourly rate in Y dollars. After 2 years, what's the plumber's hourly rate after 8 years? Right? Go ahead and fill out the key. The key is there for you already. And there's number 2. So if you want to go down and just go ahead and do number 2, just do number 1 for now, and then we'll pause again and we'll do number 2. Right? You could press pause and doing number 1 right now. Press pause. Okay, so we are back, and hopefully you did this already. If you're following along, if you're truly following along, and this is to the 8th power, and it's 17, so it's y equals. What's the plumber's hourly rate? It's 17, and it's dollars. $17.24 per hour. Pretty good. All right. Just wanted to bring something up in case you didn't realize. See, the B is 1 minus the R, right? So 1 minus 0.03 is your B. That's 0.7. Right? We don't see that basically because you're putting it into the calculator. But they could give you this, the 0.07, and they could ask you, what's the rate of decrease? All right, what's the rate of decay? Right, and you would have to say, all right, 1 minus, you would know that it's minus what equals 0.07. So 1 minus 0.03 would equal 0.07. And then from there, you would get a 3%. Then obviously you get 0.03, and then convert that decimal into a percentage, and that's the amount of decay. All right. And so I just did this. Yep. So so I had nobody to stop me. And guess what? I'm sure there are people out there saying, hey, wait a minute, Mr. Viola is messing up here. Yes, I did mess up. First off, I did not slow it down, and we were doing decay, and guess what? This one's an increase. So I messed up the formula, and hopefully you didn't do what I did. I'm going to change that, and change that, and change this, because it's going to be more per hour. He starts out with $22 an hour. His hourly rate is increasing 3%. So this is out, and this is out, and I'm sorry for that mistake. So here we go. But you're still using the same rate. You're still using the same initial amount. But let me just go grab that calculator again. Instead of that 22, this could happen. This definitely could happen. It happened to me. It's going to happen to you, maybe. Maybe, hopefully, it didn't happen just now to you, and that you didn't erase what you did, according to what I have. So let's see. All right. So here we go. 27.87 per hour. Okay. always look at what it says, increase or decrease. I just took it for granted that we were doing decrease questions and decay questions, and all of a sudden there was an increase one, right? And remember, every time it says increase, if it doesn't say it like that, you know that you have to add. All right, and go on to number 2 and underline all the most important words and press pause now. All right, so I have my key on the side. This is a decrease decay problem. So suppose you multiply the car for 22,000. The value of the car decreases by 20% each year. So the initial price of the car is 22,000. The decay factor is B. That's the B. So do you know that the decay factor has to be the 1 minus the rate? That is what I was talking. Whoa, that is what I was talking about before, right? So remember, you're talking about 1 minus the rate. So we're going to do 1 minus 0.20 to get the decay factor. And if you put that in your calculator, and you'll get that B, that's what you'll get. So we'll do 1 minus the 0.20, because you're changing the decimal into you're changing the percent into a decimal, and you get 0.8, and that is the decay factor. 0.8 is the B. Right, so just be aware of what that is, because that's definitely some type of question that they get asked over and over again. It's something that that they will ask, and just be aware that it's there and you have to figure it out sometimes. So it's 1 minus the R, which is the 0.20. And in this case, it says 6 years. C, it says find the value after 6 years. And that is not the right 6. And now we just grab our calculator, hopefully beyond this point. And it's 22,000. Then it's 220,000. Open parenthesis, 1 minus 0.20. And it's 6 years, after 6 years. So that's how much is Y equals 5,767.17. And that's about it. Right? I messed up on the next page. I was supposed to delete it from the page before it, but I didn't. So just go to the next page, the fast finisher. As far as the exponential growth or decay question, the fast finisher, the price of a TV is 1,500. The price decreases by 6% each month. Write a function that represents the price, the amount of the price Y in dollars of the TV after T months. What will the price of the TV be after 4 years? Graph your equation on your calculator. And that shouldn't be a question. It says graph your equation on your calculator. Can we put an exclamation point? All right, so go ahead, press pause now. Now, I'm not really sure if this question is written the correct way, or it was meant to be this way, but if you read it, it says the price of a TV is 1,500. Price decreases by 6% each month. All right. Write a function that represents the price Y in dollars of TV after T months. What will the price be after 4 years? Okay, so the key, which is right over here, so if you put 4 in for T, that is incorrect at this point. Because that is not what the question is, this question is asking. Even though it would be a good question, it's not what the question is asking. So T is 4 years, but the TV decreases 6% every month. Every month. So you have to figure out how many, if it decreases 6% each month, 6% each month, then you have to figure out how many months in 4 years. And you do 12 times 4 for the year, because it's 12 months in a year, and you get 48 months in 4 years. And that's the T. So if you put that in for T, you're going to figure out how much this TV is worth after 4 years, with it depreciating 6% each month. All right, remember, it's not just depreciating 6% each year, it's depreciating 6% each month. And there's really going to be nothing left of the value of this television. The T is 48 months, and then you press enter, and this is what you get. It's Y equals, the TV is worth $76.95. Congratulations. All right, if you put 4 in for the if you put 4, then you just in for the T, then you just basically figured out a 6% decrease every year. All right, per year, but it's a 6% decrease each month. Right. So I don't know if the question was, it is a fast finisher question. It's meant to be a little bit more difficult and take you a little bit, a little bit beyond a little bit of thinking. But that's the final answer for that one. Right? So we're up to the exit slip, and go ahead and see if you could do this. Press pause now. Okay, just taking a look at Sal and Kathy bought a boat for $5,200. Obviously, you're going to underline 5,200 immediately, and you're going to say this is your initial value. This is your A. Right? The boat loses. That's the big word there. It loses 20%. So you're going to put this as 0.20, and that is going to be your R. Right? Write a function that represents the value after T years. And then, well, you need a T. The T is 8. And I made my key, which is what you should do every single time. That's supposed to be a start. All right, so A is 5,200. Sorry, A is 52,500 volt. The rate is 0.20, loses 0.20. So you know that you're using the decay formula, the 1 minus R. And the T is 8 years. So I set up the formula here, substituting A in 52,000, and then 1 minus 0.20 to the 8th power. I'm going to grab the calculator, which is everything that you should always have in front of you. 52,000, 1 minus 0.20, and then to the 8th power. And then you press enter. and it is I made a mistake. Okay, and then it's to the 8th power. And let's try this one more time. And we have y. This boat is 8,808 and it gets rounded to 0.04. So that's the value of the boat. Just remember that b is 0.8. If they gave you that and they asked you what the percentage of decrease would be per year, you would have to figure out 1 minus what equals 0.8, 1 minus 0.20 equals 0.8. And then you would, convert the 0.20 into a decimal, into a percent, and it would be 20%. All right, and that's how you would get that, kind of like going backwards there for that moment. All right, try this Regents question. It is a multiple choice question. Go ahead and see if you can do it. Press pause now. So if you're stuck on this question, I am not going to give you a hint, but just go ahead and graph each one of these and see if you could pick out the answer. Right? So take your graphing calculator and graph each one into y equals. They want to know which day will the amounts of materials be equal. All right. So we'll go ahead, take your calculator, and input both of the equations into y equals. Press pause now. So whenever you get a little confused about anything as far as Regents questions go, you have your calculator. So you're just putting the whatever it is into the calculator. So it says materials A and B decay over time. The function for the amount of material A is A to the T 1000 times 0.5 to the 2T. And that's what I put into the calculator. Then I put the second one in, 1000 times 0.25 to the T power. And I put it in. And then it's asking on which day will the amounts of materials be equal. So basically, it says that X T represents the time in days. So that's your X in this case, right, in the calculator. So obviously, if you go to your graph, you see one graph, right? And if you press second function table, you see for every single day that the y's are equal. It's not just the initial day. It's not just one. It's not the first day. It's not day 2. It's not just day 5. It's every single day. And that's why the answer is 4. All right. So just make sure that you understand that every time that you're faced with a question like this is a calculator question. I'm just going to do this in their heads. This is the same, basic same equation. All right, same exponential equation. All right, it's much easier to see once you start graphing it on that calculator. Once you have that calculator in front of you and you see that graph, and the blue goes and the red goes right on top of it, you know it's exactly the same. Then you confirm it just by looking at the table, and you can see that every X every day, translates into the same exact Y. And that's basically what it is. All right, I'm gonna press pause. I'll print out some notes, and you can come back. Just press pause now. All right, so just remember, always use your calculator when they're asking to find when two plans cost the same. Type both equations into the calculator and take a look at those graphs. In this case, the graphs, like when you graphed them for the first time, you saw the blue graph go and then the red graph go directly over it. It means they're exactly alike, and they are exactly the same. And confirm it by looking at the tables for the graphs. Press second function table, second function graph, and then you see exactly what I'm saying is that, all right, well, wait a minute. You have your 1, 0 starts out as 1,000. That's the initial value for both. Initial value is 1,000 for both. And then day 1, 250. Day 2, 62.5, and then so on and so forth. And it's exactly the same. All right, and that's basically your Regents question. All right, that ends this lesson. Hopefully you're well. And, you have any questions, please ask. Make sure that you are using everything to your advantage, especially calculator. You could always text us on Remind. You could get in touch with us on Google Classroom and stuff like that. All right, see you next time.